Okay, so the next thing that we have here is basically miscellaneous exercises on chapter 12. So exercise number 1 is 3 vertices of a parallelogram ABCD are ABC. Find the coordinates of the fourth vertex. So, for example, you have A as 3, -1, 2, and you have B as 1, 2, -4. You have C as -1, 1, 2, and these are the vertices of a parallelogram. And you want to find the fourth vertex. Let's call the fourth vertex as D, for example. Now, basically we said that in a parallelogram, what happens is that so basically we said that the diagonals bisect one another. Meaning that, for example, if I call this ABCD, this point over here, if I call it O, basically O is going to be the midpoint of D and B, and it's going to be the midpoint of A and C. So now these points over here, if I draw a coordinate system over here, which I just want to be in black. If I draw a coordinate system over here, what happens is that basically, if let's say that this is the x-axis, the y-axis, and the z-axis, so this point would be 1, 2, and 3, -1. So this point over here and 2. So 1 and 2, somewhere over here is for example point A. Point B would be 1 and 2. So 1 and 2 over here, and -4. So 1, 2, 3, and 4. Somewhere over here would be point B. Point C would be at -1 and 1. So somewhere over here, and then 2, 1, and 2. This would be point C. So then you have basically point C over here, you have point B over here, you have point A over here. So if I connect these, for example, in this manner, of course, you know that in the case of a parallelogram, almost always it's possible to get, for example, I could connect these points in this way, and then if I got, for example, some point over here, then if I basically connected these points, I would get a parallelogram. Or basically, if I connected these points in a different way, meaning that if I connected these points together and these points together, then this vertex would be down here. So it's always up to you which variation you want to take. But now we are going to take this variation over here. So now, since we know that basically so you know that basically in a parallelogram the diagonals basically bisect each other. As you can see, they bisect each other and they meet at this point. And this point of intersection is the midpoint of these two vertices and also the midpoint of these two vertices. So based on these two points over here, I can find the midpoint, which is also the midpoint of these two vertices. So the midpoint of A and C, is basically the midpoint of A and C, if I call it, for example, the midpoint of A and C, I call it for example O, for example. The coordinates of O would be basically A and C. So 3 plus negative 1 divided by 2, and negative 1 plus 1 divided by 2, and 2 plus 2 divided by 2. 2 plus 2 divided by 2. Now that is equal to 3 minus 1 is equal to 2. 2 divided by 2. This is 0 divided by 2, and this is 4 divided by 2, which is equal to 1, 0, 2. So the coordinates of the point O over here would be 1, 0, 2. Would be 1, 0, 2. And well, we said that this point is also the midpoint of B and D. So the midpoint of B and D, which is the same point O, the coordinates would be the same, of course, 1, 0, 2. So then I can write 1, 0, 2 is the same thing as basically the coordinates of B are basically, if I call the coordinates of D as, for example, x, y, z, then this would be basically B and D. The coordinates of B and D. So it would be 1 plus x divided by 2, and 2 plus y divided by 2, and negative 4 plus z divided by 2. And 1, 0, 2 is the same as basically, okay, so I don't really need to do anything more basically. So what I can do is I can write, for example, 1 is equal to 1 plus x divided by 2, meaning that 1 plus x is equal to 2, meaning that x is equal to 2 minus 1, which is equal to 1. X is equal to 1. And then 2 plus y, so 0 is equal to 2 plus y divided by 2, meaning that 2 plus y is equal to 0, meaning that y is equal to negative 2. And then I can write also 2 is equal to negative 4 plus z divided by 2, meaning that negative 4 plus z is equal to positive 4, and z is equal to 4 plus 4 is equal to 8. So then this point would be x is equal to 1, y is equal to -2, this point over here. -2 would be right over here, so would be somewhere over here, and 8 units up, so 1, 2, 3, 4, 5, 6, 7, and 8, and this would be the point that we are looking for. So that this would be your parallelogram D, and then the point of intersection of all of these vertices would be 1, 0, 2, which is 1, 0, 2, which would be basically 1 and 2, this point over here, which goes through this point and also this point over here. That is basically the whole story here. Okay, so that was number 1. Now number 2 is find the lengths of the medians of the triangle with these 3 vertices. So the vertices are A 0, 0, 6, and B you have 0, 4, 0, and C you have 6, 0, 0. These are the 3 vertices of a triangle ABC, and you want to find the lengths of the medians. So what you need to do is, if your triangle is basically this way, let's say that you have your triangle in this manner. Okay, so basically let's say that this is the z-axis, this is the x-axis, and this is the y-axis. So this is on the z-axis. So 1, 2, 3, 4, 5, and 6. This point is A. This point is on the y-axis. 1, 2, 3, and 4. This point is B. And this point is on the x-axis, which is 1, 2, 3, 4, 5, and 6. These are the 3 points over here. So if I connect these points together, I will get a triangle like this. And then the midpoint of this side, for example, let's suppose that this is the midpoint of this side. This is the midpoint of this side, and let's suppose that this is the midpoint of this side. And this would be one median, this would be one median, and this would be one median. Now the length of the medians, you can very easily calculate them, meaning that you need to use the distance formula and the midpoint formula. For example, to get the basic, let's call this E, F, and G, these points, E, F, and G. To get the coordinates of G, you can write basically, so C is, the coordinates of C are these, so the coordinates, you already have them over here, and the coordinates of B and C. So halfway between B and C would be, so 0 plus 6 divided by 2, 4 plus 0 divided by 2, and 0 plus 0 divided by 2. which is the same thing as 3, 2, 0. This is 3, 2, 0. This point is 3, 2, 0. This point over here is halfway between A and B. So the coordinates of the point F would be halfway between A and B would be basically 0 plus 0 divided by 2, 0 plus 4 divided by 2, and 6 plus 0 divided by 2. 6 plus 0 divided by 2, which is equal to basically 0, 2, 3. So the coordinates of the point F would be 0, 0, 2, 3. The coordinates of the point E would be halfway between A and C, 0 plus 6 divided by 2, 0 plus 0 divided by 2, 0 plus 0 divided by 2, and 6 plus 0 divided by 2, which is equal to basically 3, 0, 3. This point over here is 3, 0, 3. E would be halfway between A and C, so 0 plus 6 divided by 2, 0 plus 0 divided by 2, and 6 plus 0 divided by 2, which is 3 and 0 and 3. So now the now the length of these medians, you can easily calculate them. The distance formula in the three-dimensional system is basically, for example, let's call this as general case, AB is equal to the square root of x2 minus x1 all squared plus y2 minus y1 all squared plus z2 minus z1 all squared, which is, for example, the distance between B and E. BE would be the square root of so B is over here, so 0 minus 3 all squared plus 4 minus 0 all squared plus 0 minus 3 all squared, which is the same thing as 9 plus 16 plus 9, which is the same thing as square root of 18 plus 16 is equal to 18 plus 16 is equal to 14, 34, square root of 34. So BE is equal to the square root of 34. That is one basically distance that we were looking for. The next distance, for example, would be, for example, CF, which is equal to the square root of, so this is C and this is F, so 6 minus 0 whole squared plus 0 minus 2 whole squared plus 0 minus 3 whole squared, and that is equal to the square root of 36 plus 4 plus 9, that's 13 plus 36, which is equal to 49, I suppose. 36 plus 13 is equal to 49, the square root of 49, which is equal to 7. So CF is equal to 7 units. The next distance that we have is, for example, you have CF, you already calculated, B, we already calculated, so AG, for example. AG is the square root of So A is basically this point over here, and this is G. So 0 minus 3 whole squared plus 0 minus 2 whole squared plus 6 minus 0 whole squared, which is equal to the square root of 9 plus 4 plus 36. 13 plus 36 is equal to 49, which is equal to 7. So so AG is equal to 7 units, and all of these are in units. So let me check the answers over here. Question number 2. 7 square root of 34 and 7. Okay, question number 3. Question number 3 is if the origin is the centroid of the triangle PQR with these vertices, find the values of A, B, and C. So the origin, so you have this triangle PQR with vertices P, which is 2a, 2, 6, Q, which is basically -4, 3b, -10, and we have also another point R, which is 8, 14, 2c, 2c. Comma 2c. Now, the centroid of this triangle is the origin. Which is 0, 0, 0. The centroid is the origin. You want to find the values of A, B, and C. Okay, so what you need to do basically, if your triangle is basically something like this, and if the medians are something like this, and let's suppose that this is the centroid with 0, 0, 0, and these are the vertices. For example, this is P, this is Q, and this is R. Now this centroid is 2/3 of the way from this point to this point. So if I find basically the midpoint of each of these sides, so all I need to do is find the midpoint of P and Q, the midpoint of P and R, the midpoint of Q and R, and then from each vertex use the section formula to find the values of these basically of these A, B, and C. So what I'm going to do is just make a screenshot over here because I need the space, and then I want to find the midpoint between Q and R. So the midpoint of Q and R, let me draw this triangle over here because we are going to actually need it over here. So let's say that your triangle is something like this. Okay, so I call it P, for example, Q and R. The midpoints I call A, B, and C. The midpoints I call A, B, and C. And so C, which is the midpoint of Q and R, the coordinates of C would be negative 4 plus 8 divided by 2, and then you have 3b plus 14 divided by 2, and negative 10 plus 2c divided by 2. That is the coordinates of C. The coordinates of, and I can write this as 8 minus 4 is equal to 4. 4 divided by 2 is equal to 2. Now the midpoints of basically the coordinates of A would be, P and Q, the midpoint of P and Q. So then you would get basically 2a minus 4 divided by 2, and then you would get 2 plus 3b divided by 2, and then you would get 6 minus 10 divided by 2. That's negative 4 divided by 2, that's negative 2. And that is the coordinates of A. The coordinates of B would be halfway between P and R. So 2a plus 8, for example, 2a plus 8 divided by 2, and 2 plus 14 divided by 2, which is equal to 8, and 6 plus 2c divided by 2. So then I can write the coordinates of C, for example. I can simplify it as C 2 comma 3b plus 14 divided by 2, and basically this would be negative 10 halves plus 2c divided by 2, which is negative 5 plus c. That is the coordinates of C. The coordinates of A would be basically a 2a by 2 is equal to a minus 2, 2 plus 3b divided by 2, and there you have a negative 2. And the coordinates of B would be a divided a plus 4, 8, and 3 plus c. 6 divided by 2 is equal to 3, 2c by 2 is equal to c. So now that I have the coordinates of the midpoints, what I can do is that, for example, you know that in the case of this line segment over here, PC, this point over here, which is by the way 0, 0, 0, this basically divides the line segment PC. So if I call this point, for example, G, so G divides PC internally in the ratio 2 to 1, as we discussed before. So then the coordinates of G would be equal to, basically, the formula is basically, for example, G would be m times x2 plus n times x1 over m plus n, m times y2 plus n times y1 over m plus n, and m times z2 plus n times z1 over m plus n. and so the coordinates of G would be basically M, and this is M to N. So your M is equal to 2, so 2 times something plus 1 times some other quantity divided by M plus N, which is equal to 3. Again, the same thing. 2 times some quantity plus some other quantity divided by 3. And again, you have 2 times some quantity plus some other quantity divided by 3. Now, the coordinates of G are 0, 0, 0. And so you can write basically, and over here you have x2 and x1. So now this is the coordinates of P and C. So the coordinates of P and C, I have to take P as the point 1 and C as the point 2. The coordinates of C are these coordinates, and let me write it down over here. The coordinates of C are these coordinates, meaning that 2, 3b plus 14, and plus 14 and divide by 2 and negative 5 plus C. Negative 5 plus C. So this is point 2 in this formula. Point 1 would be point P, which is 2a, 2, and 6. Now, this is point 1. Now x2 over here is 2, x1 is 2a. Y2 over here is this expression 3b plus 14 over 2, and y2 is basically this 2 over here, and then z2 would be negative 5 plus c, and z1 would be 6 over here. Next, what you want to do, so this is equal to this one. So what that means is that 0, 0, 0 is equal to 4 plus 2a, 4 plus 2a over 3, comma, and over here you would, these 2's will be cancelled out, and then you will have 3b plus 14 plus 2 over 3, which is 3b plus 16 over 3. 3b plus 16 over 3. And over here you would have negative 10 plus 2c plus 6 over 3, which is negative 10 plus 6 is equal to negative 4 plus 2c over 3. So that's negative 4 plus 2c over 3. And so what that means is that from this equation, from these, I can find a, b, and c, meaning that if 4 plus 2a divided by 3 is equal to 0, then that means that 4 plus 2a is equal to 0, which means that 2a is equal to negative 4, meaning that a is equal to negative 4 to 2, negative 2. Then 3b plus 16 by 3 is equal to 0, meaning that 3b plus 16 is equal to 0, meaning that 3b is equal to negative 16, meaning that b is equal to negative 16 thirds. That's b. and if negative 4 plus 2c over 3 is equal to 0, means that negative 4 plus 2c is equal to 0, means that 2c is equal to 4 and c is equal to 2. And that is the values of a, b, and c. Hopefully, of course, I'm not really sure. A is equal to negative 2, B is equal to negative 16 thirds, and C is equal to 2. The answer is actually correct. Okay, so now question number 4 is find the coordinates of a point on the y-axis. Find the coordinates of a point on the y-axis which are at a distance of distance of 5 square root of 2 from the point find the coordinates of a point on the y-axis which are at the distance of 5 square root of 2 from the point P 3, negative 2, 5. Okay, so you have this point P which has these coordinates 1, 2, and 3, negative 2, I'm sorry, that's actually wrong. That is actually wrong. 3, negative 2, 5, so that would be 1, 2, 3, 4, and 5. This is point P, and there is some point on the y-axis, here. There is some point on the y-axis which is at a distance of 5 square root of 2 from the point. Now let's suppose that let the point on the y-axis be, for example, A with coordinates. If your point is on the y-axis, that means that your z-coordinate is 0 and your x-coordinate is 0. That means that your 0 and y and 0. Your point, I'm sorry, no, you have the point on the y-axis. So suppose that your point moves on the y-axis. So you will have some y-coordinate, but your x-coordinate will be 0, and your y-coordinate will be 0, of course. So then the distance of that point, the distance of this point from this point is 5 square root of 2. That means that AP is equal to 5 square root of 2. So AP is the same thing as the distance formula. AP would be the square root of x2 minus x1 whole squared plus y2 minus y1 whole squared plus z2 minus z1 whole squared. So AP would be the square root of So I take this, for example, these 2 points, 3 minus 0 whole squared plus negative 2 minus y whole squared plus 5 minus 0 whole squared. This distance is equal to 5 square root of 2. And so that if I raise both sides of this equation to the second power, I get, or let me simplify this first. So this is the square root of 9 plus negative 2 minus y whole squared plus 25 is equal to 5 square root of 2. 9 plus 25 is equal to 34. The square root of negative 2 minus y whole squared plus 34 is equal to 5 square root of 2. And so if I expanded this, I would get basically a squared, which is the square root of now negative 2 minus y whole squared is equal to negative 2 squared is equal to 4 plus y squared. Negative 2 times negative 2 times y. That's positive 4y plus 4y. So over here I would have basically 4 plus y squared plus 4y plus 34, which is the same thing as y squared plus 4y plus 38. So that is y squared plus 4y plus 38 is equal to 5 times the square root of 2. 5 times the square root of 2. And so if I raise both sides of this equation to the second power, I'll get y squared plus 4y plus 38 is equal to 25 times 2 is equal to 50. And now we have this equation that we can solve. So I can negative 50 plus 38, so 50 minus 38 is equal to 12. So that's negative 12 y squared plus 4y minus 12 is equal to 0. Now 12 is the same thing as 6 times 2. 6 times 2. If I take this as 6 and negative 2, 6 times negative 2 is negative 12, and 6 minus 2 is equal to 4. So I can write this as y squared plus 6y minus 2y, which is 4y, minus 12 is equal to 0. And y times y plus 6, negative 2 times y plus 6 is equal to 0, negative 2y, negative 12. So y minus 2 times y plus 6 is equal to 0, meaning that y is equal to 2 or y is equal to negative 6. These are the two possible answers. So the point would be 2 and negative 6. So the point would be either A1, for example, negative 2 and negative 6. So 0, 2, and 0. And A2 would be 0, I suppose, negative 6, 0. So this point would be 0. So that would be this point over here. This point over here. This is A1. And this point over here. 1, 2, 3, 4, 5, and 6. This point over here, A2. And let's take a look at these 2 points on a 3D system, see what we see over there. Over here, if I have if I have some point, let me put the points over here, and the point P was 3, negative 2, 5. 3, comma, negative 2, comma, 5. And the other 2 points are 0, comma, 2, comma, 0. And the other point is 0, comma, negative 6, comma, 0. So if you, now the point P is actually this point over here. I mean, the point that we had as P is in this system is point A, and these are the 2 points that we got. So you can see that the points actually seem to have the same distance from these 2 points. Now we can, of course, go over here and do a line segment between these points and measure the distance. Measure the distance. This distance over here, 7.07, 7.07. So that is basically that. There are 2 more exercises here, but I suppose, I don't know if you are running out of time or anything, but I'm going to stop this video if the time is already, I mean, way over the limit. Then I'm going to stop the video and I will continue the rest in the next video. Otherwise, I will just pause and then continue with the same video. Okay, so it seems that we have still some time in this video, so let's continue. So now question number 5, if is a point R with x coordinate 4, so you have a point R with x coordinate 4, lies on the line segment, so let's say that this is y and z. This lies on the line segment, joining the points P, 2, comma, negative 3, comma, 4, and Q with coordinates 8, comma, 0, comma, 10. So you want to find the coordinates of the point R. Okay, so now the problem is that we don't know really how to write the equation of a line is in 3D space. Now I know that this point, let's say that we have this point over here, and this point P is 2, negative 3, and 4. 2, negative 3, and 4. So it's somewhere over here, and 4. So that's 1, 2, 3, and 4. So this is point P, and point Q is 8. So 1, 2, 3, 4, 5, 6, 7, and 8, 0, 10. So you have 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. So this is the x-axis, this is the y-axis, and this is the z-axis. And this is this point is Q. Now there is a line segment joining these 2 points. There is a line segment joining these 2 points, and this point with the x-coordinate 4 lies on this line. Okay, so let's assume that we can well assume that basically the point R, that R basically divides the line segment PQ in the ratio, for example, in the ratio m to n. Okay, so then the coordinates of the point R would be basically R would be basically m times x2 plus n times x1 over m plus n, and m times y2 plus n times y1 over m plus n, and m times z2 plus n times z1 over m plus n. And suppose, well, of course we don't know what the ratio is, but since we know one of the coordinates of the point, we'll be able to find m by n and then put it use it in the other 2 cases. So the coordinates of the point R would be basically m times some number plus n times some other number over m plus n. Again, you would have m times some number plus n times some other number m plus n, and again you would have m times some number times n times some other number over m plus n. This would be the coordinates of the point R. And over here you have x2 and x1. So I take point P as point 1 and Q as point 2. So then that would be 8 and 2 over here. So that is x2, this is x1, y2, y1 would be 0, -3, -3, and over here you would have 10 and 4. And the coordinates of the point R, are basically 4, y, z. That is equal to basically this thing over here, which is 8m plus 2n over m plus n, -3n over m plus n, and 10m plus 4n over m plus n. And so since I can of course write, for example, 4 is equal to 8m plus 2n over m plus n, and then cross multiply, I get 4m plus 4n is equal to 8m plus 2n, 4m plus 4n, yes, 4n minus 8m minus 2n is equal to 0, and then -4m plus 2n is equal to 0, -2m plus n is equal to 0, divide by 2, which means that if I divide by n, I'll get -2m by n plus 1 is equal to 0. Negative 2 times m by n is equal to negative 1. And m divided by n is equal to 1 divided by 2. So m to n is equal to 1 to 2. So now if m to n is equal to 1 to 2, that means that m is equal to 1 and n is equal to 2. Then basically your y is going to be equal to, your y over here is going to be equal to negative 3 times n, which is equal to 2, divided by m plus n, which is 3. So these two will cancel out, you'll get negative 2. Y is equal to negative 2. And your z is going to be equal to, 10m, which is equal to 10, and m and n is equal to 2, so plus 4 times 2 is equal to 8, divided by m plus n, which is equal to 3. That's 18/3, which is equal to 6. So the coordinates of the point R, the coordinates of the point R would therefore be basically 4, negative 2, 6, which is this point over here, 1, 2, 3, 4, negative 2, negative 2, and 6 must be somewhere over here, 1, 2, 3, 4, 5, and 6, this point over here. Pretty amazing analytical geometry. Okay, there is one more question left here. Let me check my answers for negative 2, 6. There is one more question left here, and that is if A and B be the points, these points respectively, so that you have basically 2 points A, which is 3, 4, 5, and B is basically negative 1, 3, negative 7. Find the equation of the set of points P. Find the equation of the set of points. It's usually a plane. Set of points is usually a plane. P, usually, of course, such that PA squared plus PB squared is equal to K squared, where K is a constant. Okay. So now in order to solve this problem, first, let's suppose that, for example, the point P is x, y, z. Then PA would be equal to the square root of x minus 3 whole squared plus y minus 4 whole squared plus z minus 5 whole squared. And then PB is equal to basically x plus 1 whole squared plus y minus 3 whole squared plus z plus 7 whole squared. And now PA squared plus PB squared is equal to basically this whole thing whole squared, which would give you x minus 3 whole squared plus y minus 4 whole squared plus z minus 5 whole squared plus x plus 1 whole squared plus y minus 3 whole squared plus z plus 7 whole squared. Okay, so this is equal to, which is equal to x squared plus 9 x squared plus 9 minus 6x plus y squared plus 16 minus 8x y squared plus 16 minus 8y plus z squared plus 25 minus 10z plus x squared plus 1 plus 2x plus y squared plus 9 minus 6y, y squared plus 9 minus 6y plus z squared plus 49 plus 14z. Now you have x squared and x squared over here. You have x squared over here. So you have 2x squared. You have y squared over here and y squared over here. You have 2y squared. Negative 6x and z squared and z squared. So you have 2 times z squared. Negative 6x plus 2x is equal to negative 4x. Negative 4x. Negative 8y. Negative 6y is negative 14. 14y. Negative 10z plus 14z is equal to positive 4z. Positive 14 minus 10 is equal to positive 4z. And then you have basically a 9 and 16 over here. 9 plus 16 is equal to 25 plus 25 is equal to 50. 50, 51, 51, 60, 60 plus 49 is equal to 109. Plus 109. So PA squared plus PB squared is equal to this thing over here. PA squared plus PB squared is equal to this expression over here. That means that what I can do is basically this is PA squared plus PB squared. Okay, so this is PA squared plus PB squared. Now, how do I rewrite this equation? I don't know. The only way to write this equation is probably divide by 2 here. So this is PA squared plus PB squared. Let me take a look at the solution here. Okay, so it's pretty simple. So basically we said that, let me erase this part. We said that we wanted to basically find the equation of the set of points P such that PA squared plus PB squared is equal to K squared. where k is a constant. So what that means is that the distance between PA squared plus the distance between P and B squared is equal to some constant. So what we did over here was that basically we calculated PA and also PB, and we calculated PA squared plus PB squared as well, which is basically this thing over here. So PA squared plus PB squared is equal to, this is PA squared plus PB squared. Now over in the beginning we said that we wanted to find the equation of the set of points P such that PA squared plus PB squared is equal to K squared, where basically K is a constant. So what that means is that now I can write basically this expression over here, which is PA squared plus PB squared. I can equate that to K squared, meaning that 2x squared plus 2y squared plus 2z squared minus 4x minus 14y plus 4z plus 109, that is equal to K squared, right? Now I can divide this equation by 2. Meaning that I can take a 2 out here. 2 times basically x squared plus y squared plus z squared minus 2x minus 7y plus 2z plus 109 halves is equal to K squared, which means that x squared plus y squared plus z squared minus 2x minus 7y plus 2z plus 109 divided by 2 is equal to, divide by 2, you will get K squared divided by 2. And so if I take this to the other side of the equation, I will get x squared plus y squared plus z squared minus 2x minus 7y plus 2z is equal to basically k squared by 2 minus 109 by 2, which is the same thing as k squared minus 109 divided by 2. K squared minus 109 divided by 2. And that is the equation that we were looking for. X squared plus y squared plus z squared minus 2x minus 7y plus 2z is equal to k squared minus 109 divided by 2. That is the equation that we were looking for. Okay, so we are at the end of this chapter. We are done with introduction to three-dimensional geometry. So the next thing that we have here is chapter 13 of class 11. Chapter 13 of class 11, which is, let me see what that is. Class 11, chapter 13 is about derivatives and limits and derivatives, which is basically about all about calculus. So in the next video we will start with calculus, and so I'll see you in the next video. Thank you.